Hi, it's Mrs. Pope, and today we're going to talk about composite functions. Composite functions means we're going to plug one function into the other. So the goal is just to find composite functions. If you see it written this way, you may see find, the way we read this, f of g, it's not fog, f of g of x. And you'll also see g of f of x. If they exist, we'll talk about that. And we want to state the domain and range. So you have two functions, f of x and g of x. And when you find composite, you're going to put one inside of the other. So if I want to find f of g of x, that means g of x is going to be on the inside, and I'm going to find f of x on the outside. So this really just means f of g of x. So the way we do this is we start with our outside function, since f is on the outside. What I'm going to suggest is you write out the function, but leave a big parenthesis where the variable is. So we have 2 parentheses, that will be the a, minus 5. And notice what's inside of here is g of x. So I want to put the entire g of x function in for the variable. That's why I left the parenthesis there. So now I've taken g of x, I've plugged it into the variable for f of x. That's a composite function. So now let's just simplify it. So we just simply distribute the 2, so we'll end up with 8a minus 5. And that would be the composite function. So now the domain here is what x value can you put in? Once you look at these, is there any x value or a value for a you couldn't put in? No, you can plug in anything for a. And 9 times out of 10, the domain is going to be all real numbers. The only time you need to be careful is if you see a radical, you may not be able to get negative numbers under there, or if you see a division, you don't want to have 0 in the denominator. So keep those things in mind. But 9 times out of 10, domain is going to be maybe 8 times out of 10, all real numbers. And this double R denotes all real numbers. The range is what can come out of here. Well, if I plug in any number for a, I could plug in positive number, negative number, 0. I can get a negative number, a positive number, 0. I can get anything. So my range is all real numbers. This is saying what y's could come out of this. That's what range looks for, and what x's can you put in. Okay, so now let's look at g of f of x. So now I need to put the g function on the outside. So this would be 4, put a big old parenthesis, times a. And inside of here, I want to put the entire f of x function. 2a minus 5. Now we simplify. So 4 times 2a is 8a minus 5. Minus 20. 4 times. So 8a minus 20 is our composite function. The domain, all real numbers, because there's nothing weird about what I can plug in for a. And then I can also have positive, negative numbers, or 0, come out for the range, so what comes out. So that's also going to be all real numbers. All right, so now let's look at a real-world example. This will be a good time to pause, write this down, and then come back so you're not bogged down by writing while we talk about it. Okay, you should be back. Here's our real-world example, saving your money. Why the heck would we ever use this composite function stuff? Well, let me give you an example. Let's say you're going down the street to Sounds to Go, new store in the neighborhood. They have a $35 rebate and 15% discount. So you want to buy a nice audio player with some headsets. And it costs $300. This is one of those really nice ones that does everything, like makes your coffee as well. So it's really nice, costs $300. And you go in and they're like, hey, we have a sale, it's great. And you're thinking, well, if you're in the math brain, you're saying, should you take the $35 rebate first or the 15% discount first? I don't know. Or does it even matter? Just give me the deals and I want to save money. Well, let's see if it matters. So let's call x the cost of the audio player. We know it's $300, but let's just denote it by x so that we can work it out. And the rx, the first function, is going to be the rebate function. So the cost of the radio, or the audio player, whatever it is, minus $35. That's how a rebate is. You just get that back. And then the discount function, d of x, is going to be 0.85x. Now let's talk about that. If you have a discount of 15%, then that means you're only paying 85%. Normally, if there's no discount, you pay 100%, right? So if you get a 15% discount off, the quick way to figure that out is to take the 15 from 100 and realize, oh, I'm only paying 85% of the price. So let's try the discount first, then the rebate, and see what happens. All right, if we take the discount first, we want to put the discount on the inside, because the way composite functions work, you evaluate the inside, get a value, and then you apply that to the outside function. So if we took the discount first, we're going to have R of x, that's the rebate one, which is x minus 35, and notice I kept my little parenthesis here because now I'm going to plug in the d of x. So I'm going to plug in the 0.85x. So if we evaluate this, it just ends up being 0.85x minus 35. And of course we know x is the cost of the audio player, so 0.85 times 300 minus 35. If you do that and figure it all out, that ends up being $220. So that's how much it would cost you for the audio player if you took the discount first and then did the rebate. All right, now let's look at the other way. Let's do the rebate first and then the discount. Keep that number 220 in your mind. So let's do the rebate first on the inside and then do the discount. So we have 0.85 times the rebate, which is x minus 35. If we simplify this, you would end up with 0.85x minus 29.75. 0.85 times the $300 that it cost minus 29.75. And here you end up paying $225.25. So, notice there is a slight difference. So, conclusion, it is better to do which one? You want to take the rebate first or the discount first? To take the discount first, then the rebate. And as a bonus or food for thought, is this always true? Prove it. Is it or is it not? Let me know. Thanks for watching, and remember, you are responsible for your own learning.